All right, hello. We're starting on page 403. In this lesson, we're going to be going through the warm-up, getting started, and activity 1 and 2. The learning goals is describe a functional relationship as a rule, which assigns each input exactly one output. We have done this before, but we haven't really done it with this vocabulary and terminology. But anyways, let's get started on the warm-up. What we're going to do here is we're going to plug in values and determine what they equal. So we're going to plug in these values here, 1, 6, 12, and 25. These are just random values for x. And we're going to plug in for number 1. So 1 is the expression or term 5x. So what we're going to do is we're going to plug them in, multiply it by 5, and that's the number that we get. So if we plug in a 1 here, 5 times 1, that's just 5. If we plug the next one, which is 6, right, 5 times 6, 30. And let's just keep going. 12 times 5 is 60. And 25 times 5, or 5 quarters, is $1.25 or 125. Here we're going to put, since this is a set, we're going to put set brackets here. It looks like this. Let's do one more. Let's do number 2. All right, so let's plug in a 1. So we're plugging right here. So we're figuring out what is half of 1. And then from there, we're going to add it with this other 1 here. So if I plug a 1 in here, half of 1 is just a half. And 1 plus a half is 1.5. We'll write that as a mix. Whoops. We'll write that as a mixed number. 1.5. If I plug a 6 there, half of 6 is 3. 3 plus 1 is 4. 12. Now I have this one. 12, half of 12 is 6, and 6 plus 1 is 7. And the last one, 25. Half of 25 is 12.5. And then 12.5 plus 1 is 13.5. Since I'm putting in mixed numbers, I'll put 13.5 like this as a mixed number. And again, let's put our set brackets here. Okay, this really actually is our next topic, but we'll talk about those vocabulary terms pretty soon in activity 1. But let's go and get started on continue page 404. Pairing off. So it says for each graph, we're going to create a table of values. And then separately from there, it says write the set of ordered pairs in the table. Okay. So like for this point here, we know that this point is, you always go x and then y. So this is 1 and then go up 5. So this is 1 comma 5. So I can write that, I'll write that underneath here. But really what it is, I'm going to write the 5 here. That's an ordered pair that matches this. Okay. All right. So we're going to do the same thing for the other ones. So when I go at a height of 2, a width of 2, the height is 8. That is the coordinate, 2 comma 8. Actually, let's start this with set brackets here. A height or width of 3, the height is, looks like 11. So 311. Next one, 4 and 14. Oops. And the last one, we go 5 to the right, and you could think about this as going 17 up. So that is 5 comma 17. And then we'll close the set bracket there. We're going to forego example 2, but you're welcome to do that as you do. Let's get started on activity 1. Okay. All right, we have a lot of key vocabulary terms. I would say this is probably the most important page. So if you want to put a star here on page 405. So the vocabulary terms that we have, it says the ordered pairs you wrote form relations. Actually, I'm going to highlight it over here. A relation is a set of ordered pairs. So this, we just call this, right? This is all just a relationship. Or we'll just write relation. So there's a relationship between x and y values. So as you can see, as we go further right, we go more up. And then the first coordinate of an ordered pair in the relation is the input. So for this, I'm going to highlight this. I'm going to put x comma y here. I highlighted this in green, right? This is the input, right? The x value. The second coordinate is the output. I'm going to highlight this in a different color. So the output is the y value. And we kind of know this from working with slope, right? We would talk about how the slope is rise over run, or y over x, or dependent over independent, or output over input, right? The output depends on the input, or the dependent variable depends on the independent variable. Okay. Next thing here is you can also use a mapping to show ordered pairs. A mapping represents two sets of items. Arrows connect the items. So this all below here, numbers 1, A through D, are all mappings. Arrows connect the items to represent a relationship between them. And it says when you write the ordered pairs for a mapping, you write a set of ordered pairs. And a set is a collection of numbers, geometric figures, letters, and other objects that have some characteristics in common. So, right, all of this right here is a set of numbers. But we've been working with sets of numbers when we're working with patterns. Okay. Let's go and get started here. So number 1, write the set of ordered pairs that represent each mapping. So pretty much we're going to start with, you could think of this as your x and this as your y. There's more vocabulary terms that we'll learn about this, but notice how the 1 right here, this connects to the 7. So that forms an ordered pair. That is, I'll put my set bracket first, 1 comma 7. And just keep going, right? The 2 connects to the 1, so 2 comma 1. Next one is 3, 5. And last one is 4, 3. Okay, now key thing here is based on the number of arrows that you have, that's how many ordered pairs we should have. So we have 1 arrow, 2 arrows, 3 arrows, 4 arrows, and we have 1, 2, 3, 4 ordered pairs. So like for B, you may notice we have some more arrows. All right, 1, 2, 3, 4, it looks like 5. So we should have 5 ordered pairs. Here's a lot more. 1, 2, 3, 4, 5, 6. And then D as well. Okay, I'm gonna go through C. You're welcome to do B and D as you do, but let's work with this one here. All right, set bracket. So 1 connects with 1, so 1, 1. And then we have 2 connecting to 2 different things, right? 2 connects to 3 right here. And then 2 connects to 5 as well. So we're going to have a second one with 2, 2 comma 5. We have 3, 5, 4, 7, and then finally 5, 7. So notice how, right, exit, well, we have 1, 2, 3, 4, 5, 6 ordered pairs. Notice how, like, for the x's, there's only 5 different numbers. The y's, there's only 4 different numbers. But we have multiple arrows going from the x to the y's. Okay. And then separately from here, number 2, create a mapping from the set of ordered pairs, so going the other way. So a key thing here is I want you to understand, if typically for x and y's, we put them in order from least to greatest. And if anything duplicates, we don't write it twice, we only write it once. So let's look at our x's here. 5, 11, 6, and 8. So I'm going to put 2 circles here. Right, this is our x and this is our y. And what I highlighted in purple, let me write that here, but in order from least to greatest. So we have 5, I think it's the smallest of the 4, 6, 8, and then 11. And then separately from here, let's put our y's from least to greatest. Looks like it's 5. 8 does repeat, but I'm going to write it once. And then we have our biggest value, which is 9. So for here, we have 5 connects to 8. So we're going to draw an arrow from here to here. 11 to 9. 6 to 8. And then 8 to 5. Okay. All right, we're going to leave B as a you do. And then some other key vocabulary terms. So this topic is called an introduction to functions. So functions is the most important word that we have here. We need to understand a function. So a function maps each input to one and only one output. So this right here is a function. Each single input has exactly one output or one arrow coming from it. So this, right, that only has one output of 8. 6 has one output, also 8. 8 has one output of 5, and 11 has one output of 9. It doesn't matter what their outputs are, but that they have one output makes this relation a function. And then, in other words, so a function has no input with more than one output. And then the other key vocabulary terms that we have, I'm going to put this in blue. The domain. The domain of function is a set of all inputs of the relation. So this right here is what we call as the domain. Right, those are the set of all things that go into a function. And then separately from there, oops, let me put this in red. The range. The range of a function is the set of all outputs of a relation. So this we're going to say is the range. Write it sideways. Okay. So good there. So for you, try to figure out B and let me check. But let's go ahead and continue here. We do have some worked examples here. So it says here we have the domain of 1, 2, 3, and 4. So we can see that here and here. Instead of writing X, I'm going to put D for domain. And it says for this, the range, so instead of putting Y, I'm going to put R for range, is 1, 2, and 3. And you can see it's color-coded, so it looks good there. This one is a function. So this relation is a function because each input has one output. Right, 1 has 7, right here. 2 has 1, 3 has 3, and 4 also has 3. Doesn't matter if they share an output, but every input has one output. All right. And then here's the same domain, but a different range. Range is 1, 3, 5, and 7. And here we can see that this is not a function. The reason it fails to be a function is because this 2 has two outputs of 3 and 5. Right, so that's where it fails to be a function. Every input has to have one output, or when you're looking at a mapping, has one arrow coming from it. Okay. All right, moving on from there. Number 3, state why we already did this. State why the relation in the worked example is not a function. We're going to say the number 2 has two outputs of 3 and 5. All right, here we already did this. I'm going to cross off number 4. But let's go to number 5. All right, so these are the ordered pairs. Actually, going to cross off B. This number 5 is what we did earlier on getting started. Let me go back to that to remind you. That's where we had, that's where we had the graph here. Let me erase all this. Where we have this whole entire 1, 2, 3, 4, 5 points and 5 ordered pairs. So we're going to just work with that. So it says determine whether each sequence represents a function. And if it is a function, identify its range, domain and range. So I'm going to look at each input here. And does each input have one output? 1 has an output of 5. 2 has an output of 8. 3 has an output of 11. 4 has an output of 14. 5 has an output of 17. So this relation, we'll say this relation is a function. Right, so what's nice about this, there's not too much computation, but it's just a part of identifying. We do have to figure out what the domain and range are. So the domain is a set of all input or X values. So everything that I underlined is a domain. So 1, 2, 3, 4, and 5. And then the range, right, the range are all the Y values, so it's going to be what I circled, and this is also going to be in order from least to greatest. It's already in order from least to greatest, and if anything repeats, you just write it once, just like a mapping. So 5, 8, 11, 14, and 17. Okay. And then we're foregoing B. So let's go ahead and move on to the last page in this video, and that is working with varying contexts. So it says, so this is activity 2 on page 407. Functions as mappings from inputs to outputs. So we're going to determine whether it is a function or not. And so let's go and read this. So you have determined whether sets of ordered pairs represent functions. In this activity, you will examine different situations and determine whether they represent functional relationships. And then read each situation, decide whether it fits the definition of a function. Okay, and we're going to explain our reasoning. We'll probably put a sentence or so. So the input for number 1, actually we're going to do this. We'll have a couple of you-dos. Let's do the first 3. And then the second, or the second set of 3, these are all you-dos. So go ahead and just work this out and let me know what you think, whether it is or isn't a function. For number 1, input. Sue writes a thank you note to her best friend. So that's the input in this situation. The output is her best friend receives the thank you note in the mail. So is this a function? Did each input have one output? Did that note go to her friend? One note to one friend. That is yes. Sue's one note goes to one place. Or her best friend. All right, and then number 2, we're looking at a TV situation. So a TV station broadcasts a football game. So that's the input. Output is it appears on televisions in millions of homes. Okay, so in this case, did one broadcast to one home? In that case, no, right? So this is not a function. It's just a relation. We'll say that the football game maps to millions of homes, or we'll just say more than one home. Right? In order for it to be a function, it had to just broadcast to one. And the last one that we have, there are 4 puppies in a litter. In the output, the Smiths adopted 1 puppy. The Jacksons adopted another puppy. The Fullers adopted the remaining 2 puppies. Okay. So in this case, did each input have one output? This is a yes, right? Each puppy we'll say went to one home. Now the thing with this though, right? So yes, one puppy went to the Smiths. One puppy went to the Jacksons. One puppy went to the Fullers, and then another puppy went to the Fullers. But that's a different puppy though. But he still has one home. It wouldn't be a function if one puppy had 2 homes. So I don't know, maybe like joint custody between 2 different families. That wouldn't be a function. But in this case, it is a function. Anyways, so go and try to determine whether 4, 5, and 6 are functions, and then let me know.